Okay, thank you all. Thanks, Scott. Thanks for being here and listening. Here I'm showing an image of the Cascadia subduction zone where the Juan de Fuca oceanic plate to the west is subducting beneath North America to the east. Today I'll be presenting some new research in Ozette Lake, which is located along the outer coast of the Olympic Peninsula. Let's see. There we go. Okay, so why are we interested in Ozette, which is shown in this graphic with this red star on the cutaway animation? The reason is because the lake is located along a portion of the subduction zone that is relatively isolated from earthquakes that occur along crustal faults, mostly onshore, farther to the east, and earthquakes that occur way down deep within the subducting plate. You can kind of see as this animation flips through the different graphics, the earthquakes down on the subducting slab tend to occur farther east, and those are called intraslab events, kind of like the 2001 Nisqually earthquake that lots of people in the area experienced. So in other words, we hypothesized that Ozette would contain evidence for the so-called megathrust earthquakes, the big ones that occur along the plate interface beneath the outer coast. And many previous studies in other places have shown that these massive earthquakes occur about every 450 to 550 years, with the most recent one happening in 1700. And so we'll be focusing on these megathrust earthquakes for the Ozette portion of this, or the Ozette research here. And so why should we look in lakes to study prehistoric earthquakes? Well, in general, there are a number of ways that shaking is recorded in lake sediments. The most common being features like underwater landslides and slope failures, which are shown in this graphic to the right. Lakes in the Pacific Northwest often have continuous sedimentation, which provides a really ideal tape recorder of environmental perturbations, earthquake shaking being one of those. And the lacustrine sediment response to historical earthquakes can be used to calibrate the prehistoric sedimentary evidence for earthquakes. So there's a bunch of reasons why these environments are ideal. And so what kind of geological evidence are we looking for? So during a large earthquake, sediment is shaken loose from the steep flanks of the lake basin, and it travels downslope as a turbulent flow, just sort of churning up and mixing. And once that flow settles, a turbidite deposit is left behind on the lake floor. And these turbidites are recognized by their grain size distribution, with the coarsest, usually sandiest sediment at the base, and the finest sediment, which settles out last up at the top. And so the tools we use to find these deposits and other evidence for earthquake shaking involve underwater mapping and the use of multi-beam echo sounders, which reveal the fine-scale details of the bathymetry and things like landslides and sediment flows and where they might be sourced from. This is just an image of how this technique is applied in the marine environment. It's the same idea in a lake. And then we also spend a lot of time collecting sub-bottom data, or sub-bottom towing chirp instruments, boomers, or seismic reflection. And the way this works is a sound pulse. Oops, the video is not working. A sound pulse is reflected off of density interfaces in the sediment, and the resulting imagery allows us to map sedimentary units and identify places that we might want to sample using sediment coring. And so with the sediment core, we can get ground truth on the sediments that we think might contain evidence for earthquakes. And so the project objectives here in Lake Ozette, these are images from our field work in 2019, were to collect comprehensive high-resolution geophysical and geological data, and explore sedimentary evidence for earthquake shaking, and lastly, to construct a robust age model for the shaking deposits using high-resolution radiocarbon sampling and some Bayesian age modeling. Uh-oh. Looks like the, did I just lose the talk there?
Not sure what happened, but I'll go ahead and share it now.
Okay.
One moment to pull it up.
I'll keep talking here as it comes back
sorry
up.
about
So
that,
we first
Danny.
began our field work in 2019. We spent 3 weeks at Ozette collecting high resolution bathymetry data, which is shown on the left. There we go. So this left panel, this map is showing the bathymetric data in Lake Ozette. We also collected a number of short reconnaissance vibrocores, sediment cores, shown as black dots in that left panel. And then chirp and boomers sub-bottom profiles, which are shown in the right panel as colored lines. So you can see that the lake is separated into 2 subbasins with these elongate deep water basins separated by a bathymetric sill. And then all of the significant stream inputs are located along the eastern shoreline of the lake, and stream sediment is being concentrated into that eastern basin.
You'll have to take control again.
Oh, thank you. All right. I wonder what was. And then the second phase of our field work was in 2021. We mobilized a UETech coring platform. This is operated by the USGS in Santa Cruz. We recovered 12 to 14 meter long cores from 3 sites and bottomed out in glacial outwash. That suggests we sampled the entire Holocene and latest Pleistocene sediments. This video here is just showing the coring operation when we were in the lake. I'll be showing some more details from these data here shortly. And so all of the cores were scanned in an X-ray CT system with a multi-sensor core logger and photo logger at our facility in Santa Cruz. Cores were sampled for radiometric dating. A total of 160 radiocarbon dates were extracted from the upper 10 meters of sediment spanning the last 14,000 years or so. This image just shows our sample extraction approach, where we dated material, organic macrofossils from directly above, below, and in between each turbidite layer that we identified. And then most of these were very delicate organics like spruce seeds and leaf fragments, the kinds of things that you would expect to have a very short residence time in the watershed. And so here I'm showing a type section chirp profile. This is a cross section through the lake sediment in the western basin. Oops. I wonder if I should have you guys do this. I'm having trouble taking control.
Should I like me to advance the slides?
Yeah, can you go back? Would you
Sure.
be? I'll stop control. I'll just ask you to. Thank you. Sorry about that. Okay. So this irregular chaotic section towards the bottom represents stacked mass transport deposits or landslide deposits, and then above the dashed green line are these parallel laminated strata. And so we've interpreted this boundary to represent a major environmental transition from the interglacial to post-glacial period at about 14,000 years ago. And then the dashed red line is where we sampled a tephra deposit that was determined to be the Mount Mazama or Crater Lake eruption at about 7.6 thousand years ago. Next, please. And so next, I just want to go through 3 quick examples of what these turbidite event layers look like in different parts of the lake. Here I'm showing the gamma density wiggles, the CT intensity, and photo logs for cores located at the distal, intermediate, and proximal sites. in these lower panels, we're looking at enlarged views of these discrete event layers. The brighter colors represent higher densities in the CT intensity. Next, please. Each of the event layers is normally graded, with the sandy material being concentrated at the base. And then in between are these laminated background accumulations of fine-grained sediment. The main difference between these sites is in the thickness, which increases dramatically from the proximal basin into the deltas. Next, please. And here I'm going to show an example profile of this site near Umbrella Creek. Next, please. Where we see a lot of evidence for slope failure and submarine or subaqueous landslides. And what you see in this, you can see these chaotic units nearest the delta sort of grade basinward. And then these cores reveal that these bright reflections in the chirp data are actually turbidites. The youngest one is 1700. And so we asked this question, how do we know these are actually generated by shaking? And one of the arguments we make is that in this post-1700 accumulation of sediment near the top there, this is a time period where there were numerous floods and high discharge events, including commercial logging and deforestation. There are no turbidites. So this, along with a couple other things, suggests that these were in response to strong shaking in the basin. Next, please. And I'm going to show an example of this long core that we collected in the proximal basin. Next, please. At this site here, off of Sawash Creek. Next, please. And what we've done is superimpose our core log on top of the chirp data. Each of those darker wiggles you see in the image are turbidite event layers. Next. And this movie is going to just scroll down. I think if you click play, you can see each of these deposits represents a shaking event in Lake Ozette. And as we scroll down near deposits 17 and 18, we see the Mazama tephra at 7,600 years or so. And then we start to bottom out in the glacial outwash. Okay, next, please. We've dated each of these event layers. The details are not important. If you click next, please. But we have a really robust record of radiocarbon dates on all of these, and we have 17 events, 17 earthquakes since the Mazama ash, 16 before, and 33 total. So that gives us a recurrence of about 420 years. And so what is the significance here? Next, please. The significance really is just that the Ozette record is remarkable. It's one of the highest quality, highest precision records of earthquake shaking in the Cascadia region. We have, again, 33 events in 14,000 years. And it's a good example of how these lacustrine environments can be used to expand and improve upon megathrust recurrence estimates in the Pacific Northwest. Okay, last slide. I just want to thank everybody who's contributed, including the National Park Service, especially the Ozette Ranger Station and facilities staff in the Makah tribe. Sorry about those issues with the advancing the slide issue. I got hung up there, but I'm happy to take questions if there's time.
Okay, it looks like we got about 2 minutes for a question. If there's any questions, if you want to raise your hand or you want to put it in the chat, that'd be great. Getting some good applause here. Let's see. Any questions at all for Dan? There we go. Heather asks, what material collected for radiocarbon dating is most sought after for dating in the lake bed?
Yeah, that's a great question. What we find to be best are these intact seeds, the kinds of things that you would expect to be relatively fragile and wouldn't sort of swash around in the Ozette watershed for many years. They just end up being blown onto the lake, they sink, and they get buried and they're preserved. So sort of the more fragile plant material tends to be the best. We find things like spruce seeds in particular are quite good.
All right. Any other questions? Again, if you don't get your question answered right now, looks like we might get somebody asking. If you don't get your question answered right now, we do have an ability to do this. One quick question. Do you have spruce seeds throughout?
We have probably, I'd say about 50% of our samples contain spruce seeds or at least fragments of spruce seeds. And then in other cases, we were using leaf fragments. There was an abundance of material of high quality material overall. And I see there's another one about uncertainty. The uncertainty we put on the recurrence interval. I think it's plus or minus 60 years. I should have included that.
Perfect.